Right, our first thing we're going to look at is Lewis dot diagrams. We're going to start with something that's quite easy. It should be a recap of year 12. Our second video will be on when it's hard to follow the octet rule with an easy one, and then our third one is going to be some major exceptions to the octet rule that are new for year 13. So the SciPad has got a good process for how to draw Lewis dot diagrams. I've got a different one. Just do the one that works best for you. So my way of doing this has sort of 4 steps, but there's a bit more to each one than what it sort of says. So I'm going to walk you through this twice, once for quite a straightforward one and once for a much harder one. So the first thing I always do is I think about what the purpose of a Lewis dot diagram is, and that's to show the bonding electrons in the lone pairs, because that will help me understand shape and therefore polarity. So that's why I'm doing it. So the key thing is that a Lewis dot diagram is only looking at valence electrons, the outside electrons, the outermost electrons, the ones involved in bonding. So the first thing I'm going to do is I'm going to add up the total number of valence electrons. In my example, I'm going to use NCl3, so nitrogen trichloride. Nitrogen has got 5 in its valence shell, and we can check that on our periodic table. It's in group 15. They have 5 valence electrons. Chlorine in group 17 has got 7 because there are 3 of them. That's 21 electrons. So we're going to add up all of these. So 5 plus 21. This Lewis dot diagram has to have 26 electrons when I'm finished. The next thing I'm going to do is look at the valency of each electron. Now the valency is how many chemical bonds can it make. The valency of chlorine is only 1 because it's got 7. 1 more will make that 8. So the valency of chlorine is only 1. And the valency of nitrogen, having 5 electrons, is 3. It can make 3 more chemical bonds, adding that up to 8, our octet rule. So nitrogen has got the higher valency. Therefore, I'm going to draw it as my central atom. I'm then going to use bonding pairs to attach each of these chlorines to nitrogen. So I'm going to put a chlorine here, a chlorine here, and a chlorine here. Now, each of those lines represents a bonding pair of electrons, so 2 electrons. So we've already got 2, 4, 6 of our electrons used. So we're down to 20 left over. I'm then going to use lone pairs, and I'm going to use crosses because it's easier to see on a whiteboard than dots. I actually recommend you use crosses rather than dots or circles in an assessment answer as well, to fill these up. And the way that I normally do it is I fill up the outside atoms so that they obey the octet rule, and then if there's any left over, I put them on the central one. So 8, 10, 12, 14, 16, 18, 20, 22, 24, I've still got 2 left to get to my 26, and there I've got 26. So let's just have a look at this. Does each element obey the octet rule? Nitrogen has got 2 for this bonding pair, 2 for this bonding pair, 2 for this bonding pair, and 2 for this lone pair, so 2, 4, 6, 8. Yes, it does. Does each chlorine? Well, they all look identical, so I'm just going to do it for one of them. 2 for this lone pair, 2 for this lone pair, 2 for this lone pair, and 2 for this bonding, because it's a covalent bond, they're shared. So yes, it does as well, which means these ones do as well. So I've been able to use the lone pairs to satisfy the octet rule for every single element. The next video is going to look at one that's a little bit harder than this. But we'll finish this one here.